Hey there. My name is James, and I am a virtual expert of Merehead company. Solana is a popular Ethereum alternative. It has extra low transaction fees, impressive transaction processing speed, and high scaling potential. It has a lot of advantages, including more straightforward Dapps development compared to Ethereum. Solana functions on Rust, C, and C++ programming languages. So in this video, you will find out about the blockchain's benefits for blockchain project launch, and the process of creating Dapps on Solana, namely its features, steps, technology stack, and cost. Solana is an open-source platform designed to be a scalable, secure, and utmost decentralized environment for tokens, smart contracts, Dapps, NFTs, and other blockchain solutions. Anatoly Yakovenko, Greg Fitzgerald, and Eric Williams launched the startup in 2017. Anatoly and Greg are programmers who worked for Qualcomm, and Eric Williams is a doctor of elementary participle physics who worked for CERN, the Large Hadron Collider. Technological features of Solana. From the technological perspective, the Solana ecosystem is a technology cluster that works with a protocol to boost speed and scaling. The ecosystem employs the Proof of History (POH) protocol. This protocol is a decentralized clock. The idea is so simple that everyone is wondering why it was not invented before. The decentralized clock integration makes the blockchain function significantly more effective. Proof of History is not just another consensus mechanism. It is a unique synchronization algorithm designed for Solana. The main task is to set a single time stream of events and put timestamps on each block without complex time and energy-hungry computing, like the Bitcoin and Ethereum chains. Thanks to the timestamps, the validators can work on the transactions faster, which reduces the network strain and enhances Solana's bandwidth. But for the decentralized clock, Solana's blockchain has 7 more innovations that boost the transaction processing and improve the smart contracts, ecosystem potential, and scaling. Tower BFT, a Byzantine fault tolerance BFT variation that protects the POH from harmful pools that want to hack, slow down, or stop the system. Gulfstream is a transaction redirection protocol that allows Solana to function without a mempool. Through Gulfstream, the transactions in Solana's blockchain are validated faster significantly and cost less. Cloudbreak, a unique mechanism that tracks the user's balances. It helps the system read and records users' account data simultaneously. As a result, the system works faster. Archivers is a node network structured like Filecoin. These nodes store validators' data and get rewarded in tokens for this effort. Turbine is a protocol designed particularly for Solana. It allows the nodes to share blocks similar to the torrent network process. C-level is a smart contract parallel processing mechanism. Pipeline is a mechanism that processes 3 blocks at a time. 5 advantages of employing Solana. Instant transactions. At the current stage, Solana can process about 3,000 transactions per second, which is 175 times more than Ethereum and 430 times more than Bitcoin. Furthermore, the testing team claims that if the validator's network grows, the blockchain will easily handle from 65,000 transactions per second to 190,000 TPS at peak loads. Yet, it is not the limit, and the team promises to reach 700,000 TPS shortly. Small transaction fees. Another significant advantage of Solana for smart contracts and Dapps is super low commissions. For comparison, processing a transaction on Ethereum costs $3.19 while NFTs and smart contracts cost $20 to $100. Easy to use for development and deployment. The primary programming language on Ethereum is Subject-Oriented Language Solidity. The speech was designed specially for Ethereum in 2014. However, the Dapps product on Ethereum has limitations due to a low number of experts that know Solidity, and few of them will work for an acceptable price. Solana requires using the Rust programming language for Dapps and smart contracts. Rust is considered one of the most popular programming languages in the world. Hence, you won't have trouble finding experienced talent. Furthermore, the project team developed the LLVM, low-level virtual machine protocol, that helps compile smart contracts and applications coded in other languages for WASM, C, C++, C#, Go, etc. LLVM allows transferring smart contracts and applications from WASM networks into Solana. So it is much easier to find experienced professionals for Solana development, and the cost of their work will be much lower compared to Ethereum. No mempool issues. Mempool is the waiting zone where initiated yet not approved transactions wait for validation. One of the tremendous Solana benefits compared to Ethereum, Bitcoin, BSC, Avalanche, and Tron is that there is no wait zone on Solana. Since the transactions on Solana are processed at outstanding speed, there is no queue. These queues are typical for Ethereum and Bitcoin. Therefore, the users have to compete, thus increasing the transaction fee. Low resource consumption. A shared ledger system has a specific task: recording, storing, and transferring data. Depending on the ledger, fulfilling the mission will require different resources. For example, let's imagine a blockchain with 1 million active users. When a block is created in the network, all participants must receive the information, which requires massive data transfer between them. The more participants, the bigger the traffic. This may result in issues with scaling, which will slow down or stop the system if the traffic volume is more significant than the bandwidth of the blockchain. Turbine Protocol, which functions like torrent networks, helps Solana solve this issue. It splits each block into numerous bits so that each node downloads a part and distributes it to other participants. This approach reduces the load on the network, since data is transferred in smaller volumes from one participant to another, without involving the network's limited bandwidth. Moreover, the turbine also eliminates data redundancy, which increases the safety of the network. How to develop an application on Solana. Developing decentralized applications on Solana usually involves several steps: initiating the project, searching for a developer, developing the smart contract and interface design, testing and deployment. Step 1. Initiating the project. Launching any startup, including Dapps on Solana, starts with defining the project's concept and business targets. Before searching for a developer and beginning the development, you must specify the purpose of your application and its target audience. Not only that, but the clearer you understand the logic of your application, the easier it will be to find the right talent to implement your idea. Step 2. Searching for a development company. The second step of developing dApps on Solana is finding a skilled blockchain developer. Moreover, the developers must have experience launching blockchain solutions in your sector. For example, if you want to create a cryptocurrency exchange, you will require a developer with similar projects in the portfolio. Likewise, if you wish to make a blockchain platform for tracing supply chains, find someone with experience in this sector. Speaking of the programming skills, the development team must meet the following criteria. Coding knowledge. Apparently, to develop applications on Solana, you will need developers with knowledge of Rust, C, and C++ languages, since these are the primary languages for Solana. In contrast to Solidity, Rust is easier to learn and doesn't require experience and rich knowledge. Therefore, the language is widespread, and the community is more advanced. Front-end expertise. The front-end framework, Vue 3 single-page application, SPA, and other solutions make interaction with applications on Solana easier. Vue 3 SPA functions on JavaScript. This is why the developers must have experience in JavaScript too. Step 3. Planning the dApp development. This step will require you and the development team to plan the application creation thoroughly. Namely, it will involve making a description of the project, a development plan, and defining what you will need for it. This plan will lead the developers through the other steps. You must consider the following things within the plan. Project tasks and goals. The volume and the estimated cost of the project. General work progress. Team roles and obligations. Main project milestones. For example, meetings and result reviews, editing and approving edits, etc. Confirming that everything will be done in time and within the available budget. Step 4. Developing the smart contracts. Smart contracts or smart contracts combination is a place where the inner logic of your decentralized application is based. It will include the actions that will automatically execute the dApp. For example, exchanging one cryptocurrency for another, or crypto-secured lending. Solana smart contract development requires working on the smart contract logic, developing the gateways and the API of the dApp, integrating dApp to Solana blockchain, developing the dApp infrastructure. Step 5. Designing the interface. Theoretically, you can build your dApp without developing the standard mobile and web user interfaces focused on more direct end-user interaction. Moreover, your app will even work fine. However, only users with a good understanding of smart contracts can use them. If that's not your option, you'll need to develop an effective user interface with a pleasant and intuitive design and navigation. The creation of such an interface usually takes place in several stages. 1. Creating the low-fidelity wireframes. It is a simple sketch of the interface design illustrating the main elements and functions. 2. Creating high-fidelity wireframes. Designing the detailed user interface as seen by end users. 3. Developing clickable prototypes. Application design where all components, including buttons, transfers, animations, videos, etc., function, yet the main process is still unavailable. Remember that initiating a smart contract through the user interface takes some time since the blockchain transactions are not instant. A good idea will be to add an animation to the interface to show that the process is going and the application is not frozen. Also, adding integrations with popular cryptocurrency wallets will make the registration more accessible, which is a good idea. You should also consider that the users might want to study your application before connecting their crypto wallets. So do not hide your functionality and application design. A solution will be creating a text or video instruction with a detailed description of functions. Step 6. Making the server part. If you are building a DApp that requires massive data storage, or you plan to run other features beyond the capabilities of blockchain or smart contracts, then you will need a central server part. Such a server part will connect to smart contracts and the application interface so that clients can offer additional features to you, the business owner, to manage your DApp, and to users. Step 7. Testing the product. As with any other project, before you offer your app to users, you must thoroughly test it to remove critical bugs and errors and achieve the proper performance and high level of security. Every new build of your decentralized app and smart contracts must go through a quality control process. In the case of running DApps, this means not only standard testing procedures, functional, regression, cross-platform, usability, security, and performance testing, but also smart contracts testing, which involves using a test network to verify its functionality and security. Step 8. Deployment. As a final step, you need to deploy your app, which includes adding a smart contract to the blockchain, adding mobile apps to the App Store and Google Play marketplaces, and switching the internal portal to a working environment. In terms of maintenance, it's more of an ongoing process. Even though the smart contract will remain unchanged, you still have to update the user interface, making it more user-friendly. That's all for today. Thank you for watching. Subscribe to our channel and don't forget to like this video. If you need any help, just let us know. Have a good day with Merehead.